Welcome to the University of Pittsburgh's Health and Explainable AI podcast. I'm your host, Jordan Gass-Poore, a health and science reporter. Join me as we cover advancements being made in health informatics and explainable AI for students, researchers, and healthcare practitioners interested in applications of artificial intelligence and machine learning. This podcast is produced by the University of Pittsburgh's Health and Explainable AI Research Laboratory at the University of Pittsburgh School of Health and Rehabilitation Sciences Department of Health Information Management. Headed by Ahmad Tafti, Pitt's HexAI Lab cultivates extramural collaborations with academic institutions both nationally and internationally through its research, educational contributions, and this podcast series. Hello and welcome back to Pitt HexAI, a podcast series produced by the University of Pittsburgh's Health and Explainable AI Research Laboratory. I'm Jordan Gass-Poore, your host, and today we're going to speak with Jason Fries, a research scientist with the Shah Lab at Stanford University. Welcome, Jason. You've been doing amazing work around foundation models and data-centric AI. We're super excited about having you on the podcast.
Thank you for the invite. It's great.
Well, I guess one of the first things for me that I would love some clarification on, because I am a science journalist. So I just want to better understand just right off the bat that when we're talking about computer science, healthcare, and the work that you do, what does that actually mean?
So computer science is a very broad discipline that touches a lot of technical aspects. In computer science, there is a particular discipline of machine learning or artificial intelligence. That's how to train or build models from data that can learn to do interesting, useful tasks in the world. And so, in a healthcare setting, we can imagine a lot of such useful tasks that we would like to automate or, supplement human performance for things that are quite challenging for a human to manage, either because just the scale of data, like you can imagine looking through pathology slides that are huge or stuff that are just super time consuming. You want to think about ways that artificial intelligence can assist in these day-to-day processes of conducting medicine with which to improve patient lives and reduce costs, particularly relevant in the United States, where we have a very big problem with the runaway healthcare costs. And so healthcare in AI and computer science really is the intersection of the practical utility of what is needed to do better medicine and the technical innovation required in the computational space to sort of accomplish that with the desired properties of efficiency, cheapness, and scalability.
And then what got you interested in this field in particular?
It's kind of particularly in computer science, I kind of came to a weird route. So I never had a proper computer as a child. Actually, my first introduction to computers was like a literal antique called a Commodore VIC-20 that was thrown away by a neighbor that I played around with. So it wasn't until actual college that I had what you call a modern computer. And so I kind of came out of high school really interested in medicine, and I was sort of geared up, sort of mentally preparing to go into neuroscience or some sort of medical field. But I took I bought a computer by the time I went to college, and then, I was taking a bunch of life science courses, and I sort of just was way more fascinated with the computational building aspect of computer science. And so I quickly sort of diverted to a computer science field for my undergraduate. And, I still obviously infatuated with medicine and sought all these high, goals of sort of working in that space. But I really was attracted more to the idea of building stuff versus maybe the tradesmanship of learning how to conduct medicine. So I was very, very lucky in my undergraduate career at the University of Iowa that there was a research group there called the CompEpi, Computational Epidemiology Research Group. And they were doing some really fascinating stuff monitoring disease spread using social media. And they were one of the first research groups to use Twitter for predicting influenza outbreaks. And they were spinning up this giant initiative in the hospital to essentially monitor through data human movement, how you interacted with other healthcare workers, what rooms you entered, and the interplay of that with the spread of hospital-acquired infections, and sort of how that translated to corresponding health behaviors like hand washing and everything. And I really, that was this was like 2007, 2008. So it was a completely mind blowing, like it opened my mind to all of this new potential, particularly as we start thinking about computational ways to do all this. And that really was my gateway to thinking about grad school and then eventually, how I ended up where I am now.
Yeah, I mean, thinking about that time period too, wasn't that the time about like MRSA outbreaks in hospitals? And if I remember
Yeah,
correctly.
there were a lot of yeah, exactly. And like, we worked a lot in C. diff and these sort of like endemic problematic diseases. So one of my co-advisors, Philip Green, was really involved in a lot of, those types of outbreaks. He was really interested in those types of things and how we could maybe track and predict them using like, crazy data, right? Like from how the room was cleaned, how prior occupants may or may not have had infections. And so all of this was just really fascinating and pretty, advanced, I guess, for the time. Like I didn't realize then how like sort of ahead of the curve we were, but we had all that in the context of actual healthcare data. Like we had access to EHRs and clinical notes, and then movement data. We had architectural diagrams of the hospital, so we could build like fine graph-based structures of movement. And so, yeah, it was pretty incredible for predicting stuff like disease outbreaks, or what we did a lot was sort of building social networks to optimize like vaccination policies. So you could sort of pick particular hub and spoke type individuals to optimize for administering, a limited budget of vaccines.
And so then with that, how did that work that you did back in 2007, how does that influence the work that you're doing now? I mean, obviously I see a lot of parallels because of the COVID-19 pandemic and everything
Yeah,
too, but if that previous work has any sort of influence on your current work.
it definitely does. I mean, I think, the most obvious is that, it's what led me directly to a postdoc at Stanford. So it's sort of, I was very lucky to be in kind of like, the catbird seat of having access to data that directly led to my, getting a postdoc with the Mobilize Center, working with Chris Ray and Scott Delp, where they were really interested in taking healthcare data and situating it with, they were particularly interested in like movement, the human movement and diseases of movement, like osteoarthritis. And so it was very, exciting. And it set up this idea that I think I still carry today is like, we really need to contextualize health in this very multi-layered, multi-level way with data. And it starts sort of one layer is at the hospital and how you interact with healthcare workers, but there's this whole other world on top of it, from the action of conducting healthcare if you're in the hospital to even outside of the hospital in your day-to-day life that may or be revealed in social media or increasingly with devices, which I think was really exciting for the Mobilize Center. And again, they were quite early. I mean, I think this stuff is huge now, like monitoring from devices, but circa 2015, like we weren't quite at the level we are now with the sophistication. So I think it's, like all good research, it's sort of way ahead of its time and like it's reaching its moment sort of now. And so I think that absolutely colors, where I come from now in my thinking.
And then speaking of where you come from and where you're thinking right now, I'm always interested mainly because I'm the only journalist that I know of in my family. And my family always asks me, what exactly do you do every day? Like, how do you spend your 8 hours a day? Because I don't know about that. And so I like to ask people too in other roles outside of journalism about how you spend your day to day. So curious what you do for those 8, 9+ hours, because it's Silicon Valley, so
Yeah,
you might be working more than that.
yeah, that's yeah, yeah. I try to maintain a work life balance, but it's quite interesting. Like, I'm officially a research scientist, and that's sort of it's a different role based on the lab you're in because it's very much the relationship with the PI. And I have a very, I work very closely with Shah, who's really excellent and generous PI. The research scientist role is quite a shift, I would say, from my graduate school and then postdoc days, in that I get up, fairly early, and a lot of what my immediate responsibilities are monitoring a lot of ongoing projects, and that's sort of mentoring students, PhD students, master students, or other folks like that, and sort of getting updates on where projects are, and that can be anywhere from like 2 to 4 projects in various states of disarray, depending on how close to mature they are. And so a lot of that is just sort of syncing and updating, talking a lot on Slack, and then sort of shifting to like one-off meetings depending on the project. That's the most of, if you're familiar with Paul Graham's sort of maker versus manager view of the world, a lot of what my research scientist day is manager role. And that is I sort of have a lot of quick meetings that are all about sort of deriving value, right? Or maintaining the value and making sure we don't make sort of bad steps that could really hurt us in the long run. But that's very different than classic student sort of maker schedule where you're like, I want to take 2 days to really deep dive into coding or understanding a problem. And I try really hard to maintain a space for that since I think it's frankly critical for being a good researcher is to sort of stay up to date on stuff and always be using latest technology and building your own sort of ML tools. So I try to carve a couple days, 1 to 2 days a week practically, so that I can have a more of a maker schedule where I don't take meetings and do more classic. This is when I'm going to code for several hours or I'm going to write for several hours. And I'd say that, and then the sort of standard mix of lab meetings, which can be big fun group distinct of where everybody is, or like Stanford's really generous in the sort of the collaborator community in that people are very easy to walk across like the street. And you have CS and medicine and bioengineering, they're all within like the same corner of campus. And so we have a lot of exchange. People come over for meetings and big collaborations. And so we have a big group around, medical foundation models that's quite fun during the school year that meets and does a lot of, brainstorming and catching up on what's exciting. And so that's a pretty good gist of my sort of average week. Conferences are the other big craziness where everything goes out the window. There's a deadline, but generally it's the pretty consistent.
What kind of student projects are you managing these days?
So it's a lot of stuff around, kind of like baby PI behavior. Like, Nigam and I work very closely in sort of defining research goals and research projects. And so a lot of what we're doing more recently is around, a lot of large language modeling for healthcare type of questions. And this runs the gamut from building models, like how do you build these more efficaciously and cheaper and more reliable, to like how do you evaluate them, and even on the further spectrum, like how do you deploy them. And so these are all in various states of sort of inquiry as research projects, but there are people working on each sort of axis. Nigam has a pretty good sort of worldview of this triangle of building, evaluating, and deploying, and we sort of have people operating at each corner of the triangle.
And, I'm curious as well about because Stanford does sit smack dab in the middle of Silicon Valley and all of this, I think, culture that a lot of us just have an idea about and have not actually lived or experienced. And so wanting to get a better idea of how the Silicon Valley culture impacts your work and the work of your students.
I think it is a really fantastic aspect of being at Stanford. It's just the connection to, people who are excited enough in your work to give you money and see it. Maybe, there's so many problems in academia that we arrive at a solution, but it's like a sketch, right? And so to really actually have the impact that you want, it really does need to be turned into some sort of commercial entity or sort of have different trade-offs than what are present in the academic life. And so, there is an argument to be made. Not every research project directly translates to some VC startup, but a fair number of projects do, I think. And if you can walk into a research project with a strong conception of its benefit, and that benefit can be communicated to people with money, and the stakes are pretty clear, that's a great place to be. And I think encouraging students to think about problems that way, like, is this important enough of a problem that if I solved it or if I made progress, people would be really excited and give me money to keep doing it. And so that is a kind of clarifying property for a large space of problems to really focus on what does matter, what will have immediate impact. There are obviously tons of research that doesn't quite have that glide path to business, but there is a lot of opportunity here on Stanford to find the problems that do. And so I think that's a real benefit here of this community.
And expanding on that a little bit further, because thinking about like from my perspective as a journalist, going through J school, that we never had the business 101 kind of courses. So if you had an idea that eventually like you wanted to start your own local media outlet, you kind of had to find your own resources or go get a business minor. So thinking about then students who are entering these healthcare fields that are doing the research projects, that how do you help prepare students then to be able to, if they want, to be able to pitch their ideas to VC funders or to companies?
Yeah, totally. I think it's a great question. And I do think that kind of type of training is not sort of as easy in other places as it sort of is here for some reason, just because of the place we are. But I think encouraging your research communication skills is a strictly like table stakes benefit for any student. And it's sort of that happens to co-occur a lot of with what VC people like to hear is that you really should have an elevator pitch to really get people excited in your research. All of that stuff carries over to whoever you're talking to. And I think one of the really nice properties of Stanford is that there are so many folks here that have done a lot of really successful startups. This can be at the faculty level, it can be a lot of the student level. Many students finish their, PhD or masters and go into the startup land. So you have this rich sort of network of people to plug into for advice. And often, by and large, everyone is extremely generous with their time and discussing advice. And that goes all the way up to the VC folks themselves. They're often very generous and want to work with you. So if they, another big thing is once you've honed your pitch, which sells to academics, hopefully also sells to a general audience. That's really critical. Academics are notoriously terrible communicators. I think Stanford encourages you to not be a terrible communicator and all of the benefits that come therein. If you can give a pitch, like at a great internal even Stanford venue, I think it opens up a lot of doors where people ask you to meet for coffee or invite you to a VC firm to discuss more. And people are really willing to work with, like if you have a good idea and you work hard and you can communicate that idea to a set of humans, it's a pretty good prior that you can find some degree of success in sort of this, in a VC landscape. And the more killer your idea is, the better you'll be. But I think that's sort of the baseline energy here that's encouraged and sort of how you pick up on how to sell stuff.
That makes sense. Before we jump into foundation models, in preparing for the interview, you mentioned you submitted 2 manuscripts to, is it pronounced NeurIPS? Like neural?
NeurIPS, yeah.
NeurIPS. Okay, so it's the
Yeah.
Conference on Neural Information Processing Systems. So curious about the papers that you submitted, that if you'd be able to summarize both of those for us?
Yeah, absolutely. So the first paper is led by one of our PhD students, Ethan Steinberg. He's been really instrumental in driving a lot of the technical innovation with building healthcare foundation models. Where when we say healthcare foundation models, we mean, actually taking the structured medical codes that are present in a patient's medical record and treating it as a sort of pseudo language where you're predicting in sort of a language model, you predict the next word in a sentence is sort of how these models are built. Well, you can directly translate that to any sequence of events. And so with the healthcare model, you're predicting what's the next disease code or diagnosis or treatment you'll observe in your timeline. And so he's been working on his entire dissertation for building better ways to build healthcare models using all of the medical data available at Stanford. And motor sort of represents his final culminating artifact as a PhD student before he graduates. And it really is the intuition that the classic way of training these models, which is called autoregressive, really only looks very shallow into the future, like the next thing. The next thing might be literally the next code within the day. It might be what happens tomorrow or, your next visit. But the notion of time is very sort of localized. And so he has the intuition that there is, if you look at the average medical record, there's huge amount of temporal structure about the journey a patient is going to take in the healthcare system and their health. And so his sort of insight was, well, we have a lot of rich models in modeling time to events, which is to say, we're not always just concerned if an event will happen. Will you get cancer? Yes or no? We want to know when you will get cancer, sort of the risk of how that changes over time. And so he has built a foundation model called Motor, which uses this time to event formulation to generate thousands of pre-training tasks using a medical record system like Stanford. And by pre-training a model at that scale, we've trained it like at Stanford scale, which is 3 some million patients, and on claims data, which is at 50 million odd patients. If you train a foundation model at this scale, how well can you do compared to sort of current state of the art time to event modeling? And what he found very nicely and demonstrated very compellingly in his paper is that this pre-trained model just has dramatically better benefits. It is more performant given the same amount of training data than state of the art. And really excitingly, you just need wildly less data to perform well. So you actually found that you needed 95% less data to train the same performance of a model. And that's really just absolutely critical for medical settings where it's either really expensive to curate data or you just don't have a lot of it often for certain diseases or phenomenon of interest. So getting that data efficiency optimized is a huge win. And the paper explores the sort of technical nuts and bolts of doing that. And for one of the first models to do this, we're planning to release the model. So that sort of dovetails with the second paper, is that data sort of machine learning in healthcare has a real reproducibility crisis, right? We aspire to protect patient data, and we aspire to sort of be mindful of these data security concerns and governance. But the result of that is that we have no sort of shared language of data sets with which to compare results. And that's the norm in standard machine learning, where we can talk about performance on a data set and we sort of have a shared language for understanding progress. And what happens in healthcare is that we build our own thing on our own data set and it seems like it does better and nobody can verify it. And that problem is, exacerbated when we're now talking about foundation models, because it requires so much data to train that if you can't share the model, it's even more difficult to verify sort of benefits. And the second paper is sort of speaking to that exact problem. And we called it earshot, which is sort of a clever pun on EHR shot, but spelled like earshot, you hear it. And it's really saying, well, we want to evaluate foundation models in medicine under this property of data efficiency. Like, how little data do we need to get a good performing model? We want to evaluate the transfer learning, how well a model can be taken from one institution and evaluated on another data set, and what are the trade-offs of that lift and shift? Because that's sort of the promise of foundation models, is that you can train a big model somewhere or on a bunch of data sets and then share it so that everybody can sort of receive the benefits of not needing as much data. So we've actually released, as part of earshot, or are releasing 7,000 patients worth of data. So this is getting to the scale of like Mimic, which is really the big driver in healthcare data sets. And we've released their full longitudinal timelines, which means everything they've had an encounter with the hospital. And our foundation model that can then transform that into a representation for evaluating models. And so now we have a universe where we can make a claim and we can back it up. We can give you the data to replicate it. You can take our model and transform your data into the same format and see how well or bad it performed. And I think that's just like the level set that's desperately needed to sort of, buy our own claims that these really have these properties we want. Well, we need to measure them in different places than other people with other eyeballs on it. So that's what that paper sets out to do.
That's great. And when do y'all plan on releasing that?
It's under review, so it's public. The earshot paper, at least, is open on data sets. It's an open review process. So what's really nice about that particular track is it has this month-long kind of community discussion period of sorts, so that we can, because data sets really, I think a lot of different voices should be heard, and it should be a lot of interesting opportunity to refine and iterate. So that's ongoing as of tomorrow. And so if the paper is in fact accepted, then it would be presented in December. And the hope is that we would have the data set ready for final release at that point.
Oh, that's great. And I mean, I understand too that on top of, or in addition to foundation models, that you do a lot of work around data-centric AI. I'd love an explanation on the difference between data-centric and model-centric AI.
Yeah, absolutely. Yeah, no. So I was again really lucky when I came as a postdoc that I was working in Chris Ray's lab, and particularly I joined his lab around the time that Alex Ratner joined, who started his dissertation, which would eventually become Snorkel AI. And his real interest is in weakly supervised learning, which is really one of the early forays into what we now call data-centric AI. And it's really the realization that sort of classic machine learning in a research sense really focuses on the advantages and trade-offs of the architecture of the model. That would be like a convolutional neural net versus a recurrent neural network, and how these sort of perform on the same data. And so you fix the data set and then you optimize the architecture has been the classic model-centric view. But as we've kind of got more sophisticated as a field, looking at how to deploy models, what you really realize is that the data is the determiner of performance and sort of how the model actually behaves when you use it. And the data is something you can change, right? Sort of much more easily than sort of develop and vet a new architecture. And so data-centric AI really makes this argument is that, well, we're getting to this state where architectures are becoming commodified. Like Google put out the transformer, and that's sort of the baseline architecture for a lot of the innovation driving language models and other work. There will be innovations in the architecture front, but a sort of slower scale than other avenues. But what the real differentiator is like, well, we need to get experts to curate data. We need to build better data sets. There's a great paper out recently called like Textbooks Are All You Need that showed that just training on textbooks or high quality data for coding did really, really well. And it just gets to this idea that we should be thinking about the data we feed these models and methods to make that data better. And has all of these really amazing performance benefits. Like there was a great paper in NeurIPS last year that showed we're kind of in the era of big dumb scaling, right? Like we just throw tons of data and millions of dollars in compute at something, and you get amazing results. However, that's going to run out. We're going to run out of the internet at some point, and we don't have enough data. And so we need to be smarter about the data we feed these models. And so this opens up a whole new world of thinking very carefully. And what really is nice is it intrinsically involves experts, right? Like we need to bring a bunch of people into the conversation to tell us what's good, because computer scientists don't have perfect knowledge there. That's the very reason domain experts are important. And so that's really what data-centric AI emphasizes, bringing humans in the loop to build better data.
No, that's great. And I'm thinking through though too that, how can smaller labs or universities maybe that don't have the funding or not located in Silicon Valley, how are they able to incorporate what you just talked about? I mean, how are they able to do this and do this the right way? Because it sounds like, yeah,
Yeah,
that it's pretty costly and, a lot of people.
yeah, I mean, even at Stanford, it's hard. It's easy to get demoralized when you see Meta throwing like we will never out like we don't have the compute scale in any of academia, I would say, to beat Meta or Google at their scaling game. So the question is like, well, what do we do as researchers? And I think the data-centric AI perspective is one such route where we say, well, let's focus on smaller scale stuff and really what's where does the human inject in the loop? What are the trade-offs of how they produce data? And we can really get into the weeds of exploring benefits there at the scale that can be run on research grade hardware. And so I think that's the kind of sweet spot to live, especially as we see this universe where increasingly open source models, like the great open source community around Llama 2, of making that smaller and easier to run. I think it's opening up this universe where we can benefit from this massive allocation of effort from the big companies, but still focus on the research questions using this ed infra to really to drive innovation in a way that actually matters.
Switching subjects, I'm curious, what takeaway would you like to share with students about explainability?
So explainability is an interesting facet of understanding models. And I think the goal is kind of noble, but I think it's a little misplaced in that what we think about explainability as a human perspective is really like anthropomorphizing what a model is doing. Like a model is just a mathematical probabilistic artifact that is either a stochastic parrot or a really sophisticated data mimic, depending on your bent, but it's a tool. It's a tool at the end of the day. And so when we want explainability, I usually prefer the term inspectability, which is to say that can we decompose a model into sort of constituent elements? Upon those elements, we can measure with some certainty their performance or properties. And so in the language modeling front, chain of thought reasoning is one way to decompose reasoning. Increasingly, we have tools like sort of tool former, which is to say a language model isn't like reasoning about everything, but it's asking for help from APIs or other models or systems that we can verify and build trust into. And so this whole notion of decomposing a machine learning problem into kind of the equivalent of show your work, like do this, calculate this derivative, but show every step that it took to get there. That's the guardrails and inspectability by which we can build trust in the model, which is really what we want. Explainability is just the proxy for trust. Like, I understand how this decision came out, and I can use that to inform how I will act or react to the model's output.
Thinking about explainability and data-centric AI, are you familiar with DC Check and work being carried out by Mihaela Vandershaw's lab at the University of Cambridge? Her lab is looking at ways of standardizing design considerations relevant to the development of data-centric systems and machine learning pipelines.
I'm familiar with Michaela and that lab's work. And so I think the idea is extremely the right direction, in my opinion. So I think those types of initiatives where we think very carefully about measuring data and quantifying success, I think are all the more important in the future where, deployed machine learning is in the space called ML ops, like, so how do you operationally run a model in a deployed setting? And it's a whole wide sort of open area on what the right thing to do is there. But it's so deeply tied to data, particularly in these domains like healthcare, that we really need to think very critically and formally in a community way, right? We need to engage and discuss and revisit the proper protocols for measuring success and building in guardrails.
All right. Well, we are closing out my list of questions that I have. But I do want, before we go, I did want to ask, and we asked this question of all of our guests, to really try to think about maybe a project or, something that you would like to see students interested in health informatics be able to pursue. So again, if you had a research project idea, something you'd love to see students work on, would love to be able to share that with our listeners.
Totally. I think that's a great question. I think the thing that I guess I'm really excited about is the by models, like language models, becoming so more accessible. I think we're really interested in this exciting time of breaking down how experts think about decision making and assigning labels. So computer scientists and informaticians classically, we sort of reduce things sometimes to like a bit, like one label, yes or no. It's very reductive thinking for a lot of very complicated problems. And I think the ability to sort of take a very powerful language model, open data set like Mimic and increasingly stuff like we hope to release, I think it opens up this world where we can say, well, what does decision making actually look like in terms of data? How can we decompose steps? Can we learn it automatically from data in a more nuanced way that provides it in a more accessible format? Or can we even just the labeling idea more generally, can we decompose them into elements that can then be shared across different institutions potentially? So there's this whole style of interacting with language models called chain of thought reasoning, where it does a really interesting job of breaking apart the sort of step-by-step kind of like show your work aspect of problem solving. And I think really having that in some way that we could scale with healthcare data would be quite transformative because it's very hard to extract information like that kind of knowledge from some sort of structured clinical guidelines. Like we really want to capture it in some way that reflects a data set. And so I think language models' ability to extract that, curate it, and potentially disseminate it either for education or like training more models, I think is a really interesting avenue that encourages students to think more nuanced about what a label means, right? Like I think the curse of model-centric AI is it abstracts away the label. And that's like the most important part about a machine learning model. So we want people to think more carefully about that aspect of the loop and how a human plugs into it. And I think language models just open the gates for really interesting research around those types of questions.
So Jason, it's been a pleasure speaking with you today. We appreciate you joining us. And just curious that if you'd like to leave any takeaways for our listeners or give a shout out about any upcoming events or to any colleagues that are doing great work.
Yeah, first, thank you so much for having me on this podcast. It was a really excellent discussion. And I would like to shout out to all of the, I am simply stating all of the amazing research done by the people in our lab. Certainly, Nigam Shah, who's the PI, and then definitely our students who are really doing the bulk of the work. I'm just sort of shouting in the corner sometimes for people to do stuff. So Ethan Steinberg, who's been driving a lot of the foundation model work, and then Michael Warno, who really has a paper that just dropped yesterday on sort of the shaky foundations and how we should trust and view healthcare language models. So I encourage people to check that out. He did an amazing job with some other lab mates and sort of characterizing the landscape of language models in healthcare. And then all of the other, amazing collaborators of which we have been very lucky and blessed to interact with at Stanford. And give a shout out to all of them.
Jason, once again, thank you so much for joining us today. Thanks everyone for tuning in and for following the show. The Health and Explainable AI podcast is produced by the University of Pittsburgh's Health and Explainable AI Research Laboratory at University of Pittsburgh School of Health and Rehabilitation Sciences Department of Health Information Management. I'm Jordan Gass-Poore. Thanks for listening.